guys. Now we're gonna look at the most optimized solution for count set bits. So this solution takes big of constant time. So this is a constant time algorithm, but it requires some pre-processing before it can deliver it. So let's talk about the basic idea here. We divide our input, that is our 32-bit number, into sets of 8 bits or 8 chunks, we could say. So these here are 8 chunks. This is an 8-bit chunk and this is an 8-bit chunk. So you know exactly that 8 bits are equal to 256, right? Or you can say 8 bits can give you 0 to 255. So you need now I talked about some pre-processing, right? What is a pre-processing in this algorithm? So the pre-processing is we have to iterate from 0 to 256, and for each number we have to calculate the number of set bits. Now you would say, okay, to count a number of set bit for even a number, we uh, we used to take theta of number of set 1 bits according to the previous solution, the optimized solution. Then how are you gonna take out all the set bits from 0 to 256? I'm gonna tell you an easy way to count this number of set bits from 0 to 256 using a table, right? This is the pre-processing I'm talking about. So let's directly jump into the algorithm. So the pre-processing is I'm gonna create a table, int table, and this table will take 256 elements, okay, all integers. Now I'm gonna create a function, and this function is gonna run before any other code, and this function's name is initialize. Okay, this takes no argument or parameter. Then it initializes the first element of the table as 0. This is important. If you are using Java, then it's already initialized. Then after that, we're gonna run a loop as I told you earlier for int I is equals to 0 to I less than 256 or less than equal to 255, and increment I by 1. Now what I want to do in this loop is for each integer from 1 to 256, I'm gonna put the number of set bits into the table. So for table ith element, how can I calculate the number of set bits? I can calculate if the I know for sure how to calculate if the last bit is set or not. I simply have to take I and 1. This will tell me if my last bit is set or not. For example, 101. This is a binary representation of 5. If I take and of this binary representation with 1, that is 001, I get 1. 0 and 0 gives me 0, 1 and 0 gives me 1. It gives me 1, right? So it tells me that the last bit is 1. Now it tells you the last bit is 1, but it doesn't give you the count of all the bits. Then how would you do it? It's kind of a divide and conquer algorithm if you look very closely. I will add this output of this with the previous records which I've already pre-processed. That is table of I by 2. You remember very uh, clearly that I by 2 actually removes the last bit, right? If you divide something with 2, it will remove the last bit and it will give you these bits, like this number, or you could say. If I remove 1 from here, from 1 of 1, what I'm left with is 1 0, which is nothing but 2. So I can look up into the table which I have already pre-processed if this 2, what is the number of set bits for this 2, and I can add it here. Okay, so for example, in case of 5 only, the last bit was 1, so the output of this this was 1. Then I add it with table I by 2. I by 2 is 2, 5 by 2 is 2 actually. So I find the value of table of 2 inside table, and I know for sure that this will also return me 1, because set bits in 2 is 1 only, right? You demonstrate the binary representation as 0 1 0, so there is only one bit which is set, so it will give me output as 2, and which is the correct output. For 5 there are only 2 set bits, so this is the program to count the set bits from 0 to 256. This is the initial pre-processing. I want you to remember this very clearly because I'm gonna remove this. So I hope the basic of calculating the table is clear to you. Now let's move ahead and see what we will do with this pre-processing. I think you have gotten the basic idea, right? But then too, let's write the code. I'm gonna write down the main function here, which is gonna count the number of set bits in the parameter passed by the user, that is int n in this case. Now I'm gonna write down int res. I'm gonna initialize res as as below. Okay, I'm gonna explain it now after I write it because it's a little tricky but easy. Don't worry. So n and 0x f f. Okay, what is this? No need to worry. It's very easy. What I'm Let me explain what is this Jimbo. Okay, gibberish. So this is nothing but 8 ones. It's a representation of 8 ones. So 1 2 3 4, 1 2 3 4. So these are 8 ones, and this is my number. Let's suppose my number is the one we took earlier, which was what, 10 uh, 1101, right? So 1101, and all the zeros, 4 zeros ahead of it. When we do AND operation of this with this, what will we get? We'll get nothing but 0 0 0 0 1 1 0 1. Nothing but all the last 8 bits of this, right? All the last 8 bits, because I'm hoping for this program the number is 32-bit representation. But in the given example which we have taken, there are only 4 bits which are necessary. But then too, let's imagine that these are 32 bits. So we get this number. This is nothing but binary representation of the number we took earlier, right? So the reason we took AND operator was to remove all the other bits and only take 8 bits in the observation. But why? Let's see. So this number, for this number, we can easily find the number of set bits because we have maintained the table there. The table looked like something like this. For 1, there is one set 1 bit. For 2, again there is one set bit. For 3, there are 2 set bits. For 4, there is one set bit, 1 bit set. And then there is 5, which there are 2 set bits. We have already calculated it. For this number 2, what is this number? This is nothing but 1 plus 4 plus 8. Okay, that is what, 13. So we can here calculate. We have already calculated 13 here, right? In the table, in the lookup table, through the initialize function which we've discussed before. So we easily know how many numbers are there in the 13. How many set bits are there in the 13 number? So let's imagine, now you will say, okay, we got the answer, but we have imagined that the number is 32 bits. So we have to look up for other 16 bits, for other, sorry, for other 24 bits too. These are only 8 bits which we have looked into. Let's right shift all the bits of the number by 8. Now these all bits which we have observed right now will be right shifted. So they are gonna cancel out, right? They are all gonna cancel out now. And the new RES will be RES, the previous RES, plus again table of the new n and all the ones, eight ones, right? This again takes all the 8 bits into observation, the last 8 bits. I again highlight this operation gives you the last 8 bits, and then those 8 bits are converted into decimal and then looked up into this table, the pre-processed table, which gives you the number of bits in O of 1 constant time, because we have already uh, pre-processed all the integers between 0 to 256 into the lookup table. After this, we add up the response of the other 8 bits which we got after right shifting the previous 8 bits. We add it up to this response. Obviously, this is gonna be 0 because there are no set bits up before this, right? These are all 8 zeros, and before that also all zeros, right? So this gives us again, so here also RES value will remain 13 plus 0, that is 13. Now we have covered 16 bits, we have to cover 16 bits more. Then again we're gonna right shift 8 again to the following code here repeated. After that again right shift by 8, but this is the last time. And then same similar code will be here. Now we have covered all the 32 bits. For each 32 bits, we first convert. So let me just give you the conclusion here, because this is over. This program is over. This happens. This chunk of code is repeated nothing but 4 times, because this chunk of codes only take observation for the last 8 bits. After that, we right shift all the right 8 bits. So the before 8 bits overlap the current last 8 bits, and then again we look up for the into the lookup table for those 8 bits and calculate and add up to the previous response. Okay. So basically, in conclusion, let me give you a simple statement what we are doing. First of all, there is a pre-processing. In the pre-processing, we take numbers from 1 to 0 to 256 and count all the set bits. We keep that record in an array. We use it for further calculation. So in the main count program, we first find out the last set bits. We found out the last 8 bits. Okay, of those 8 bits we have to calculate how many of them are set. So we take the help of the lookup table which we have calculated earlier. It gives us some response, the let's say initial response. After that we have to check all the other bits except for those 8 bits we have calculated. For that we right shift it by 8. So the current 8 bits are overlapped with the bits which are on the left, and so on. So this is a very simple algorithm. It takes theta of constant time, but it takes some pre-processing. Thank you.